Perfect.
All right, good deal. So getting started here today, I want to thank everybody for attending. We're going to go over user shapes today, and we're going to be talking about user shapes in general, almost like an introduction to user shapes, but along the way we're also going to be showing some of the new enhancements that came to the user shape capability in Wizards with CADWorx 2016. So we're looking at a high level of value for everyone, whether you're using user shapes now or you're curious about using user shapes and how they can help you. So just very quickly, a brief introduction to user shapes. User shapes are basically utilized for specialty items or anything that we need to be hopefully spec driven and therefore standardized that is not part of a standard engineering piping spec or our CADWorx parametric table components, okay? And going over these bullet points here a little bit, the user shapes do promote standardization through spec driven user shapes. So if I have if I don't have my steam traps in my specification, then I might have 4 guys on the floor that all model their own steam traps and maybe do a generic attach on them so they show up on the bill of material, or they might approach things differently. So we're promoting standardization using these user shapes, as well as giving a much more efficient way to model these things. So once the user shapes are created, utilizing them in the modeling environment is just as efficient as modeling in CADWorx. The user shapes become available on your spec view palette. They become available in the router in the plus script functionality. So it does increase efficiency there as well. Also, the second bullet point there, increasing efficiency by reducing workarounds. It's not uncommon for substitute components to be used. Let's say we have a flanged flow meter. I've seen several companies that were using bleed rings so that they could put in a non-standard length bleed ring component for the takeout for the flow meter, and then they'll double click on that, change the long description, maybe even change the S key if they want to change the way it's being represented on the isometric drawing. But that's all, case by case fat finger modifications to componentry, and we want to avoid that if at all possible, and user shapes are the solution to that. Okay, leveraging vendor-provided 3D solids is another big efficiency increase where we're not required to reinvent the wheel or do any AutoCAD 3D modeling. If our specialty items are provided as 3D solids, we can leverage those 3D solids from the vendors. And occasionally we may encounter, something that was done in SolidWorks or something that was done in another 3D product. And typically we can either import those and explode them and use the surface sculpt command to turn those into AutoCAD 3D solids so that they can be made into user shapes. If you're experiencing any hang-ups or file format issues, we're glad to help. So don't hesitate to reach out to your CADWorx support provider. Okay, accurately represent detailed geometry and specialty items. This is still falling back on the vendor-provided 3D solid bullet point there a little bit, but one of the added benefits is using these vendor solids, we are, we're certified. This is going to be the real estate that this component is going to take up. If we have the need for overly geometrically rich models for model reviews, or if we're down to very congested areas where we may be getting down to ½ inch, 3/4 of an inch clearance because of a highly congested area, that highly detailed geometry can really be very valuable. Okay, and for all of the user shapes, you can always create a desirable representation for isogen output. So, we're customizing the long descriptions. They're going to be called out on the bill of material the way we want them to. The graphics customize, whether we're using an existing S key from our skey.pdf, which we'll go over here in a few minutes, or we are building a full-on custom S key. We won't be getting into building custom S keys today, but we will show the S key functionality a little bit there. On the topic of the custom S keys, especially when we start getting into highly specialized components like sanitary valves, it's basically a hunk of 304 stainless steel that's been bored out into a valve, and you know, we have some very unique geometry there and a lot of connections. That's where the custom user S keys will really come in very valuable. And there was actually a webinar I would encourage you to look at that was done by Dominic Hepp that goes into that very much so in depth. Okay, so moving on here. Applications and details. So how are user shapes leveraged? When should we be using user shapes? And we use user shapes for everything from specialty items like steam traps, flow meters, things of that nature. Instrumentation, you know, a lot of us use the isogen supplementals for our instrumentation callouts, and in most applications that is adequate, but in some cases the additional geometry is required or desired, so we can create PIs, we can create all types of instrumentation as 3D user shapes, and they can be included in the bill of material if needed, or they can be excluded from the bill of material the same way we use existing checkboxes and things of that nature. Another application for user shapes would be purchased assemblies. Every once in a while I'll get a call and someone will say, hey, you know, we're buying our orifice sets as an assembly. So, you know, we only want that to show up on the bill of material one time as a purchased item with a part number. So that's another example of something you can use a user shape for. Yes, you could model those out in individual pieces every time you insert them, or you could use the CADWorx Assembly Manager to build those orifice assemblies. But if the desired result is a single line item on our MTO or our isobomb, then we would want to approach that as a user shape, okay? And then you would be grabbing your orifice flange assemblies off of the spec view palette and dropping them in as a single item. Okay, vendor solids where needed for that additional geometry we were talking about earlier, but also I want to make sure everyone also knows you can build CADWorx user shapes out of CADWorx components. And this is also very important where maybe we need that accurate real estate for the component. We need the component to be geometrically accurate, but maybe the vendor solid that we're being provided with is entirely too geometrically rich. We've seen scenarios where we end up with more CAD objects or faces and edges in a vendor provided solid than you might have had in the entire pump module. So in these cases, what you may want to do is use CADWorx components, and in doing that you will be able to create accurate geometry without having excessive geometry that can cause performance issues in your design work as well as in model reviews. Okay, and the red flag here at the bottom of the screen is it a user shape or an assembly? And I talked a little bit about that already, but let's go into that a little bit deeper. Should something be made into a user shape or should it be made into an assembly? This is a question that I get quite often. And we'll talk about the difference between a drain assembly, for example, or a vent assembly, or a pump suction assembly. These are things that are standardized, however, they require individual line items. That is the kicker. That means it should be an assembly. However, if we're buying a meter run spool, which I've seen that, you know, sometimes we're purchasing a meter run spool, that is a series of components. And we might want it to look like a series of components in our design and model review, but it's going to be a single purchased item on our bill of material. So that's the case where we would want to build using CADWorx components and make that into an actual user shape, okay? So let's see here, what's next? Oh, end types. Now we're getting into the enhancements that have come to the user shape environment with CADWorx 2016. So one of the struggles that has always been present with user shapes has been the end types. Not only just how many end types you have as an option when you're selecting the end types and defining the end types of your user shape, but the male versus female end types and even the bolt functionality. So what has happened here is in CADWorx 2016, the wizard for creating user shapes is very similar that it was before, but it has been modified slightly with regard to these end types. And now instead of defining the end type as flanged or threaded or socket weld while you're clicking them in the model, you're defining their end types after they've been designated. And what that does is it gives us true end type functionality. So these end types will behave the same way as these end types do on CADWorx components with regards to your bolt length calculations. So if you select a flanged end type that needs to have a bolt length calculation done on it. So if we're doing a flow meter and there's going to be, or you wouldn't do this with a flow meter, but if there was a flanged user shape that you wanted to be able to get fitting makeup with a butterfly valve, for example, that was a limitation before, and that has since been remedied. So it will actually calculate bolt lengths based on these end types, even though they are user shapes. Also, male and female socket weld and threaded. This has been another sort of thorn in our side with regard to user shape end types. And there were some workarounds you could do by manually changing the end types in the data table after the user shape was created, but now it's all included in the wizard, the creation tool, the user create tool for making our user shapes. And you see on the pull down there, it is actually viewing your end types from your catalog. And that means even if I'm building a user shape that's like a B16.47 Series A or Series B flange, I can go grab that explicit end type from my catalog and define the end type of my user shape as that end type. So it's 100% true end type functionality, okay? It also will allow you to override the isogen symbol for the end types for your user shapes the same way you can in the CADWorx specification editor. So if we're faking up a clamped connection or a push-to-fit connection or a compression fitting, then you can override that on the spec level. So again, fewer things that have to be done to get desirable results after the user shape is drawn. It's now pretty much a 100% spec-driven desirable result. Okay, so let's see what's next. Oh, okay, so we're going to build a steam trap now. And let's just tab right over and into CADWorx. And this is a vendor-provided solid for a steam trap. And one thing that I want to point out is that this is a 3D solid. If I double-click on it, it's just a 3D solid. Nothing special, but the 3D solid is required. And where you may come into some issues, like I said earlier, is if you have solids that are coming from different platforms. And a lot of times what we can do is we can actually explode these into surfaces, and that's when you start to see all of these ISO lines and it starts to look like a mesh from Maya or something like that. And as long as this is an airtight solid, you can use the surface sculpt command and convert it right to a 3D solid. So if that had come from Inventor or that had come from SolidWorks, you can use that surface sculpt command to convert it into a AutoCAD 3D solid. Okay? So we're going to turn this into a user shape. It's going to be in our 150 spec. To do that, first I want to go into a 2D wireframe because I have some engagements here I want to be able to clearly see when I'm defining my end types. So right up here under the miscellaneous subgroup on our CADWorx Plant 1 ribbon tab, on the upper right-hand corner we have what looks like a flame arrestor. That's the button that we're going to click, and that is the wizard for creating the user shapes. Okay? Now, There's a lot of information here, but most of the pertinent information that's sort of a sand trap is already default filled out based on your current settings. So I know I'm going to be building a 3/4 inch steam trap, then I'll set my size to 3/4 inch. I'll go ahead and set my spec to the proper spec, and that way most of that information is not only filled out, but it's also going to read the default component class for the user shapes that I'm creating. I'm reducing the amount of clicking and pull down and obviously margin for error once I'm in this dialog. So here we're going to give this a name, and we'll just call this steam trap. And this is not how it's going to be represented on our bill of material or in our spec view palette or anything like that. This is going to be the name of the data table. It'll also be the name of the W block that gets created. So this is just so that I, as an admin, can come back and identify it. And you'll notice I'm not giving it a specific size. I'm not saying this is 3/4 inch steam trap. That's because each data table can be used to create all the different sizes without having to have unique data tables in our catalog for every unique size. We can have a single steam trap, unique blocks for each size, and we can control that in a centralized location on the single data table. Okay, so a little bit of bare minimum information we're going to put in here. This is going to be our long description. So we'll say this is steam trap. This is going to be threaded, 3,000 pound. Okay. And one thing that I will point out here is that this long description is going to be the initial long description. You can, after these user shapes have been created, you can go into your PRJ file and you can create long description formats to build these long descriptions, including keywords, even including custom data. So this data table that's going to be created for the steam trap is not that much different than the data table for your valves or data tables for your elbows or flanges. So after the table has been created, we can go into the catalog and leverage some of that custom data capabilities and formatting. And that goes for part numbers as well. Okay, so I've put in my long description here, and there are still capabilities for creating user shapes for the 2D double line, 2D single line. You can also still create the user shapes based on a polyline that gets revolved, but we're going to be going with the 3D solid method here in this webinar. So next thing I need to do is define my 3D solid. And before I do that, I want to make sure that my type is set to block. I want to make sure that my size is still correct. And is this going to be a reducing component? You see, you can have one reduction size for each user shape. So if I'm doing a steam trap, say, and I want to have my condensate as an actual connection point to be routed to a drain or to a storage container, then I can do that. But we're going to say select solid here, and I'll the solid. And when I push enter here, it's going to prompt me and say, pick my insertion point. Now this is going to be your first connection point. It will be the connection point that is always used when you model this user shape linearly from a router. So you want to keep that in mind with flow direction, for example. So here I'm going to select this first connection point. Okay, that's my insertion point. And now I want to define the connections. In the previous wizard, there was a button here to define connections, and you would go through and define them. It's been moved over here on the right where we still have the define connections button, but the behavior has changed a little bit. So here I'm going to say define connections, and the first connection it has you define is the insertion point that you designated in the previous step. So we want to pull in the direction you would connect to the user shape from. So if I had a threaded nipple and I was connecting to it, I would be coming from the west here. And I'll click, and you see it's not prompting you for an end type yet. In the old wizard, that's where it would prompt you. Right now, it's just saying, let's go to the next connection point. So my second connection point will be linear. I'm going to pull out here, say I'm going to connect to it from this direction. And you could do the connection point for the condensation drain, but in this case, we're going to just do the two connection points. But that being said, if we were going to do that, we would want to make sure that the connection points were done in order of collinear connection. So I would want to pick the main run first before I went to my branch, for example. Okay? And here I'll go ahead and push enter to say I'm done selecting my end types, and now I need to define them. So to define these end types, I'm going to pull over here, and you see CADWorx is pointing at whichever end type is currently selected in the pull down. So my first connection point is here. I need to define that end type. Now, the end type pull down is just like the end type pull down in the specifications editor. It's reading the current catalog and giving us the opportunity to actually pick not only that it is a threaded end type, but it is the 3000 threaded end type. Okay, and we can override the isogen symbol here if we like, and we can also define component class for the end type. This particular end type, not the user shape. This means if we are building, say, a highly geometrically accurate pop-off valve or a pressure relief valve, then you can do that with the proper flanged end types and flange rating for the pressure and relief side for that valve, and you will get the same end type checking for that. Okay, so here I'm going to click my pull down and change to my second end type, although I could just hit apply same to all on this scenario. So if I hit apply all, you see the pull down grays out, and now it's going to apply these settings to all of my connection points. And since that's applicable here, we're going to go ahead and use that option. Now, before we say that we're done and just say OK, one of the things that we want to pay good attention to here is the folder setting. When we say OK, CADWorx is actually going to run a wblock command, and it's going to create a block of our user shape and store it somewhere. And by default, it stores it in our spec directory, which is adequate. However, if we're building a significant list of user shapes, what we will run into is a mass list of blocks in our spec folder. And while that will function and does create compartmentalization that can be easily moved and transferred from one location to another or from one project spec directory to another, it's not very easy to manage when it comes time to make modifications or clean out blocks. So we want to organize this a little bit, and the bare minimum I would recommend is creating a user shapes directory within the spec directory. So by saying this, it's going to put the blocks in there. Now, if you're wanting to take it to that next level, you can create a subfolder structure for valve user shapes, meter user shapes, specialty item user shapes. That's really up to you. CADWorx is very scalable on that level. Okay, so here we're able to say OK, and it takes just a second here because it actually does write to the PRJ file and to the catalog. So it pushed that data table to the catalog, and it added the steam trap to the 150 specification, and it also automatically reloaded our PRJ files. So it's already showing up here in our spec view palette as a steam trap. Now we can model it from there, block modeling, okay, and we get the opportunity to set the orientation for the steam trap as well. We get our connection points, which are proper. And just like any other threaded component in CADWorx, it gets our plus grips there, and we're able to route and run. And we can generate an isometric drawing here. And because we let we let the CADWorx wizard give it the default user shape S key, we're going to get just a generic shape for our user shape. But that, is adequate in some cases. Here we might want it to dimension to the center. We can customize that. But here it is on our bill of material, accurately represented, and that can be done in just a matter of seconds. So big enhancements there on that level with regard to the user shape capabilities. Here, let's tab over to our poll questions, and now would be a good time, Alex, if you'd like to take a few poll questions.
Yes, thank you so much, Chad. Everyone, we have a few poll questions for you today. The first one going up on your screen right now, how does your firm currently employ spec-driven user shapes? Yes or no? Okay, it looks like the majority has voted. We'll go ahead and close this one out and share the results with you. And the next question going up on your screen. How are specialty items instrumentation being handled? Generic attach, AutoCAD blocks, standing components such as bleed rings, etc., or isogen supplemental? Alrighty, looks like the majority has voted on this one also. Share the results with you. And we have one more quick question. Have you or your firm struggled to produce desirable results when utilizing user shapes? Yes or no? Okay, and we'll go ahead and close this one out also. Thank you so much, everyone. Share the results with you. And back to you, Chad.
Awesome. Thank you, Alex. So I realize we're running a little bit short on time, but we want to build at least one or two more user shapes and talk about a couple of the pitfalls that you can fall into with some different approaches. So we're going to get started with a flow meter, and this is a scenario where we're going to use actual CADWorx components to build some sort of geometry that would represent a flow meter in our user shape. So to do this, I'm just going to start the router here, and I'll select my specification and my spec. I'll set my main to 6 and my reduction to 4. So I'll say OK, and now I'm routing. So I'm going to pick a spot in arbitrary space here, and that does bring us to that when we're creating these user shapes, we don't have to keep our origin in mind because CADWorx handles the W block command based on your insertion point when you're defining the user shape. So here I can come out and I'll just go 4 feet and we'll list out and go get a flange. So this is going to be the flange connections for our flow meter. Okay, and what we'll do here is just create some geometry here to take up the proper real estate for the flow meter here. I'll just use a 6x4. We'll put some, actually, you know what? That would create fitting makeup. Let's avoid that. Let's do a stub. And I'll show you why we're going to do that here in just a second. So we're going to go 4x6 stub in connection. And here we'll pull up, automatic, really not relevant there. But here we'll come up, let's go 24 inches. And then we'll pull over in this direction. And we'll pull down. I'll use a perpendicular snap to cut in here, and we'll use another stub connection. Okay, so let's make this symmetrical. I can just pull up here and sort of got my minimum clearance there from my stub end and my flange. And here's our geometry. This is built out of CADWorx components, but we can make this into a user shape. We don't even have to explode it or do anything like that at all. So before I get started with this, I want to make a copy of it. So I'm going to do a copy command and just do a little offset here. And you'll see why I did that here in just a moment. It's one of the benefits of using CADWorx components when it comes to building our user shapes. So here I'm ready to build my user shape. I can launch my wizard, and my size is already set. We'll just call this meter. I won't spend too much time here. I know we're getting short on time. This will be flow meter, 150-pound raise face. Okay. And here we're going to say select 3D solid, and when we select the solid we want to make sure we grab all of the components, and they do not have to be unioned at this point. We can just make sure we select everything and say enter. And now it's specifying that insertion point. We're going to grab the end point, and now we're going to define our connections. We're going to pull here to the west, define our second connection, pull it out to the east, and push enter. And again, we can apply the same to all of these, and the end type will be the flanged 150. And even though this is just a standard flange, the benefit in the new end type pull down here is that if you have fitting makeup here with the bleed ring or a butterfly valve or any other sort of non-standard bolt connection, it's going to still calculate non-standard bolt lengths based on your bolt tables. Okay. So here I'm going to say OK, and it created that user shape, and now I can route with it. So if I grab my router here, can push L for list, and under the categories now I have user shapes, and there's my flow meter. And I'll be prompted for an orientation here, which I can designate, and it's reading that flanged end type, and based on my piping rules I have it set to show me all my flange options anytime I create one of these automatic connections. So I'm picking my weld neck flange, and now that's ready to ISO. It's going to show up on our bill of material correctly, and it's not too geometrically rich. If I had gotten a vendor-provided solid for this, it might have you know, part numbers engraved on it, a flow arrow, just unnecessary geometry that could tax my machine. Now, I created this offset because you noticed that when we hit the OK button, it W blocks and removes your user shape from the drawing. But I wanted to maintain it over here so that if I'm, say, ready to create the 8-inch version of this, I can use a change size command. I'll say automatic and change the size of this run of pipe, and we'll change this to 8. Select line, what's it doing? Okay, BOP, that's fine. So we changed the size, and now we're able to create the 8-inch version. That's one of the big benefits in using CADWorx components to create your user shapes, is that when you need the solid for the different sizes, you're able to use the work that you've already done, use change size command, even change spec to jump up to a 300-pound flange. You could do that. And also, if you're changing the geometry, the takeout for the 8-inch spool may be longer or it may be shorter. You're able to modify this after the fact, and that's why we were looking at putting the stub ends here instead of the reducing tees, because now I have maintained the linear functionality of my grip. So if I need to make my takeout longer, I can do that. And then I can stretch this back over to make it symmetrical. Okay, so now I could run that same user create tool, and I don't want to create a new user shape. I simply want to add to my meter. So I'll grab my meter and say this is going to be the 8-inch version, and notice everything has grayed out while it's in 6 because that 6 is already defined. But when I go to 8-inch, these things light back up again, and I can say select 3D solid and walk through my user shape creation. Okay, so Alex, I know we're running a little short on time. That if you'd like to see if there are any questions that we can address before we call it.
Yes, thank you so much, Chad. Everyone, if you have any questions, please type them in the questions tab now. Looks like we already have a few coming in here. The first question, Chad, do you as build out of CADWorx components use S-keys from original source components?
No, they will not. By default, they will automatically get the miscellaneous componentry. So let's go ahead and look up the meter, and we can see by default, even though we built that meter out of CADWorx components, its identifier is a multi-port component. This means that it's going to be a block, or it's going to be literally a circle with end types coming off of it, depending on how many connection points and their orientations. But that's a great example of how you can utilize the existing S keys. So if I built the steam trap, for example, let's say I built that steam trap with the connection point, then what I could do is I could actually use the standard CADWorx S key for, say, a T. So I could say T overwrite, and I could say this is going to be TS SC for screwed. So then I could say OK and OK, and of course that can also be defined as the default. So if I go into my wizard here, I can define that as the default S key here, so I don't have to do it after I've drawn it. And now if you ISO that with the drain connection also defined, it will show up on the ISO as the same way a T would or a lateral. So it creates a much more desirable graphic on the ISO.
Already, let's see. The next question is, what about administration control? Rein in a user shape base from recreating user shapes, redundancy over and over again.
I'm sorry, I missed the first part of that about control manifolds.
Administration control.
Oh, administration control. I'm sorry. Would you just read that one to me one more time, Alex?
Yes. What about administration control? Rein in a user shape base from recreating user shapes redundantly over and over again.
Ah, gotcha. So one of the things that we did not talk about in this dialog box is the default, which is save to catalog. And what that does is it allows you to create your user shape using the wizard, and therefore automatically adding it to this PRJ file, but it also pushes it to the catalog. So if I open up my spec editor here, I'll get to see the spec entry for this user shape, but also we can go into the actual catalog. So under user shapes, here are our user shapes that we've built thus far. There's the steam trap, and because we sent it to the catalog, we can also open the base catalog and say go to data tables under user shapes, and it created this table here. So we do not have to recreate this user shape every time we ever have to use it. It can be, now that it has been pushed to the catalog, it can be added to any spec just by adding a regular component. So if I come here to my 300-pound spec and say I want to add a component, it's going to be a user shape. What type? It's going to be, I believe they were all under the user one, yes. And that's just like a folder organization. Until we get some capabilities to rename these, I really don't organize them very well based on that. But I can pick the steam trap here and say add. And there I've added that user shape to another spec without having to rebuild it. So a lot of scalability, a lot of manipulation capabilities there that will avoid the reworking of the user shapes.
Okay, and next question is, can I make assemblies spec-driven?
Assemblies spec-driven, yes, you certainly can. So a little off topic there, but let's look at the assemblies manager. And I assume you're talking about assembly since that was the nomenclature that you used. The assemblies can be spec-driven, as in they can be on the level of the PRJ file, which since I have the inch-specs PRJ loaded here, that's where they would be spec-driven. Or we could have them global, which makes them available no matter what specification we have loaded or what project we're working on. And that file is controlled here and can be networked for everyone to use. Now, if you were referring to the assemblies of user shapes, for example, then they are spec-driven in their native state. So by creating the user shape, it is spec-driven.
And let's see, we're running a little bit short on time here, but let's take one more question here. Can we customize the dimensions on ISOs?
Customize the dimensions on ISOs. Obviously, the actual dimensions of the components are being controlled by the 3D geometry, and how that 3D geometry is going to be dimensioned on the ISO is dictated by the S key. So if I gave this a valve S key, then it would dimension the same way my small bore valves are being dimensioned. I can also create a custom S key under the valve category and then even transfer that S key to the specialty item subgroup for my bill of material. But how they are dimensioned on the ISO is completely dictated by the S key and your style settings. So if my style settings are set up so that all of my small bore valves are dimensioned to the center of that valve, or they are dimensioned to the ends of the valves, then that is how the component would be dimensioned on the ISO.
Thank you so much, Chad. That will conclude the Q&A portion. I believe Kevin Murphy with BDS would like to chime in real quick. Kevin?
Thank you, Alex. I just, there are a lot of questions that are coming across the board, and I've been monitoring these with Alex. We will get back to you. But in the essence of time today, and but there's a lot of really good questions that this topic has. So, Chad Snyder, as always, thank you very much. And but it's good. It's good to see this many people are using user shapes and have some good questions to help out with. So thank you, everybody,
Absolutely.
for making the time today.
Absolutely. Alrighty, thank you so much, everyone. That will conclude the webinar. Chad, thank you to you again, and again to all of our attendees. We will have our next CADWorx webinar on March 1st, and the topic will be CADWorx Plant Professional Pipe Support Assembly. We hope to see you then. Thank you so much again.
Thank you, guys.